Dear students, in this section we will introduce the differentiability. It's the third section of the fifth unit. It's an introductory lecture about differentiability. In this lecture, we shall recall the definition of derivatives and then algebra of derivatives. Algebra of derivatives, that is the product rule, quotient rule, and we shall learn the chain rule. First, let's recall what a derivative is. The process of finding the differentiation is called derivative, and if f of x is a real valued function that takes only the real value, or we can simply call it as a real function defined in the interval a comma b, then if c is a point in the interval a comma b, we say f is differentiable at c, which is denoted by f dash of c when limit h tends to 0, f of c plus h minus f of c by h exists. If this limit exists, we say f is differentiable at c. If f is differentiable at every point in a comma b, then we simply say f is differentiable. And we can denote it by f dash of x or d by dx of f of x and so on. In the last year in 11th standard, we have used this formula, that is the limiting case definition of derivative, to find the derivative of the standard functions that we call as the first principle, derivative using the first principle. Now let's learn the algebra of derivatives. First one, if u of x and v of x are differentiable functions, then the derivative of u of x plus v of x is equal to derivative of u of x plus derivative of v of x, and this can be extended to any number of functions. Similarly, the derivative of difference of two functions, that is u of x minus v of x, is given by d by dx of u of x minus d by dx of v of x. Now the third case is if the functions are in the product form, that is the derivative of u of x into v of x, that is the product of two differentiable functions, then it is given by d by dx of u of x into v of x plus u of x into d by dx of v of x. And the last case is the quotient form, d by dx of u of x by v of x. In this case, we have a condition, that is v of x is non-zero for all x. Only then it is defined. So in this case, the derivative of this quotient form is given by d by dx of u of x into v of x minus u of x into d by dx of v of x divided by v of x the whole square. Next, we discuss the chain rule or function of function rule. Chain rule or function of function rule. Now let us state the chain rule for derivative. It is also called as composite function rule or function of function rule. The chain rule states if y is equal to f of u is a differentiable function, y is equal to f of u is a differentiable function where u is equal to g of x is also differentiable, then y is the composition of two functions, that is g composite f of x, which is denoted by f of g of x. In such case, the derivative of y, that is dy by dx, is given by derivative of our y is the composition of the function f of g of x. So it is going to be f dash of g of x into g dash of x. And again, this rule can be extended to any number of functions. Suppose y is a composition of three functions. Y is equal to f g h composite g composite f of x, that is y is equal to f of g of h of x, then dy by dx is equal to f dash of g of h of x into g dash of h of x into h dash of x. Or simply speaking, if u is equal to g of x and v is equal to h of x, then the derivative is going to be df by du into dg by dv into dv by dx. This is what the chain rule states, and it could be extended to any number of functions. Now let us state the basic derivatives of some standard functions. These results we can easily prove by using the first principle, or some of the results may require the derivative of the basic functions. The derivative of constant function k is 0. The derivative of the algebraic function x power n is n into x power n minus 1. The derivative of exponential function e power x is the same function e power x. The derivative of logarithmic function in mathematics, in that too in particular calculus, whenever we mean logarithm, it is always to base e. So derivative of log x to the base e is 1 by x. Suppose the base is not e, by change of base rule, we have to change the base to e and then apply the derivative formula. Now let's write down the formula of few trigonometric functions. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is secant squared x. Derivative of secant x is secant x into tan x. Derivative of cosecant x is minus cosecant x into cot x. The derivative of cot x is minus cosecant squared x.